Today we are talking about probability theory. We're talking about how to calculate probabilities as well as what probabilities are. In the next episode, we will talk about how we're going to use probabilities to calculate further statistics. So learning and understanding probabilities will help us in the future with further statistical techniques. When we use the term probability theory, what are we talking about? Well, we're talking about the analysis and understanding of chance occurrences. So we're trying to figure out what is the likelihood of something happening. And so we're analyzing what were called chance occurrences. How likely is it that something is going to happen? So probability is how frequently a particular event is likely to occur over a large number of trials. Now, when you were a little kid in math, probably 4th, 5th grade, you probably did an activity where maybe you flipped a coin 100 times to see how many times heads would come up and how many times tails would come up. And what you were doing is you were trying to find the probability of heads or the probability of tails. And this is what we call the probability of success versus probability of failure. So in that case, one of those events, either heads or tails, was what you were looking for. That was the probability of success. The probability of failure is the probability or the likelihood that you will get an outcome that you're not seeking or that you're not wanting. So how do we go about calculating? A probability is the number of possible successful events over the number of possible outcomes. So when you know all of the possible outcomes for something, you don't need to calculate or try a whole bunch of times to calculate the probability. Instead, you can do it mathematically. So what we're going to be focusing on is the mathematical side. So rather than doing 100 trials to see how many times the outcome comes up, we're going to look at the number of possible successful events divided by the number of possible outcomes. So a probability is calculated, or the kind of shorthand for it is P, little p, and then in brackets of success. And this of success here, that's going to be whatever it is that we're looking for. That's going to be the probability that we are wanting to find. So let's go ahead and look at how we're going to calculate this, and then we'll do some examples. So to compute a probability, what we're looking at is the probability of success equals the number of successful attempts or successes divided by the number of trials. So in our calculation of probability, what we're typically thinking about is doing a whole bunch of trials. So doing something over and over again and seeing how many successes we have. So if you flipped a coin 100 times, the probability of success would be the number of times that you got heads divided by the total number of times that you flipped the coin. Now, the other way of doing this, and the other way of thinking about probability of success, is to look at probability of success as equaling the number of possible successful outcomes and dividing that by the total number of possible outcomes. So basically, what you're doing here is you are taking the possible successful outcomes, so what do we consider a success, and dividing that by what are all of the possible outcomes. So again, if we're thinking about flipping a coin, there are two sides to a coin, correct? We all agree that there's heads and there's tails. And so the possibility of success, if we're saying that heads is a success, there's one head to the coin, right? There's one head. And then the total possible outcomes, you can either get heads or tails. There are two possible outcomes there. So for flipping a coin, so probability of, we'll say, getting heads on a coin flip is going to be 1 over 2 because there is one possible successful outcome, getting heads, and there are two total possible outcomes, heads and tails. And so when we're computing a probability, it's basically this ratio of successful outcomes divided by total possible outcomes. Okay, so that sounds all well and good, that we have this ratio or this division there of possible outcomes, successful outcomes divided by total outcomes. That's great, but there are some rules to keep in mind, some things that will help you as you're computing probabilities. So the first is the probability has to range between 0 and 1. If you really think about it, if we're thinking about the probability of success being number of successful outcomes divided by total possible outcomes, there can't be more successful outcomes than possible outcomes, right? So it has to be between 0 and 1. The other way to think about this is that you can also think of these as percentages. So a probability is a proportion, and when you take a proportion and you multiply it by 100, it's going to give you a percentage. And that percentage can't be above 100, right? You can't have more than 100% likelihood because 100% or a 1 is absolutely every single time you do this, that's going to be the outcome. A 0 is that it's never going to happen. You're never going to have that outcome. And so you always have to have your probability ranging between 0 and 1. So in other words, your probability of success, or P, and then you have your probability of failure, Q, and those together have to equal 1. So the probability that you'll have success plus the probability that you will have failure is always going to equal 1 because you're going to have, 100% of the time something is going to happen. You're either going to succeed or you're going to fail. There's no gray area here. There's no, well, I sort of won and I sort of lost. That doesn't really work. So P plus Q always equals 1. All right, so the second rule here is the rule of addition. So the addition rule for alternative events basically states that the probability of alternative events is equal to the sum of the probabilities of the individual events. Let's give an example. That's probably the easiest way to do this. So let's think about a traditional deck of cards. So a traditional deck of cards has 52 cards in it. And let's say that we're interested in either drawing a king or an ace. So we're going to note that as P, king, or ace. So we're interested in either getting a king or an ace. So either one of those cards will make us happy, will work for us, and so those are both acceptable cards. So the first thing we need to do is figure out, okay, what is the likelihood of drawing a king? How many kings are in a deck of cards? If you think about it, you have 4 suits in the deck, right? So you're going to have a king of hearts, a king of spades, a king of clubs, and a king of diamonds. So there are 4 kings out of the 52 total cards. So 4 successes out of 52 total cards. But we're also equally happy if we were to get an ace, right? So we're going to add the probability of getting an ace. And again, there are 4 aces in the deck out of 52 cards. So the probability that we would draw in a deck that's been shuffled, either a king or an ace, is going to be 4 over 52 plus 4 over 52, which is going to give us 8 out of 52. which equals 2 out of 13, which is equal to 0.1538, or if we're going to multiply that or turn that into a percentage, it would be 15.38%. So the probability of drawing a king or an ace is 15.38%. So in a normal deck, if you just sort of draw out a card, 15.38% of the time, you would be drawing a king or an ace. So basically, anytime you see the word or, that or is a plus sign. You're adding the probability for the first event to the probability of the second event, which takes us to rule number 3. And rule number 3 says that we need to adjust for joint occurrences. So a joint occurrence is when we have an event that double counts success or joins two aspects of success. So we have to account for that. So let's keep thinking about our deck of cards. And let's say that we are interested in the probability of king or queen or heart. So we're going to have probability queen or king, sorry about my handwriting, or heart. Like my little heart there? Isn't it lovely? All right, so there are 4 queens in a deck, correct? We know that. 4 kings out of 52 cards. And then when it comes to hearts, there are 13 hearts in a deck of 52 cards. So normally, because we have an or in between each of these ideas or each of these successes, normally we would put plus signs here, correct? But we need to account for joint occurrences because two of these 13 hearts are already accounted for here and here. Because we have 2 of these cards, one of these is a queen of hearts and one of them is a king of hearts. So we've already counted for those in our probability for queen and our probability of king. So this is actually 11 out of 52. And so if we're going to add those together, so put our little plus signs, and now we can add them together, we're going to end up with 19 out of 52. And that's going to give us 0.3654. And if we change that into a percentage, it's going to be 36.54%. So when you have joint occurrence, you need to take that into account and make sure that you eliminate double counts. Rule number 4 is the multiplication rule for compound events. Some events have 2 or more parts to them. We call them multiple part events or compound events. So the multiplication rule for these states that the probability of a compound event is the same as the probability of the separate parts of the event multiplied together. So let's think about if we were to want blackjack. So we want the probability of ace, then jack. So after we've already achieved the ace, we want to get a jack so that we can complete that blackjack. So here, the probability of ace is 4 out of 52, and the probability of jack is also 4 out of 52. And so if we want to say that we're going to draw an ace and then a jack, we're going to use the multiplication rule and multiply these together. And so we're going to have 16 over 2704, which is going to give us 0.0059. And if we turn that into a percentage by multiplying by 100, it's going to give us 0.59%. So the likelihood of drawing an ace and then a jack is 0.59%. And so this is what we're talking about with compound events, when you're saying that you have to do one thing and then do something else. All right. Okay, so that leads us to rule number 5, where we need to account for replacement with compound events. So in our previous example, we didn't do this. We didn't account for replacement. So when you have a compound event, we specify whether or not we're replacing what's been taken. So for example, in the card example before, where we were looking for ace then jack, so we had probability of ace then jack, we basically said that we had a chance of 4 out of 50, and then 4 out of 52 again. Well, the thing is, if you've already drawn one card from the deck, unless you put that card back into the deck, you're not going to have 52 anymore. You're not going to have 52 cards still left in the deck. Instead, you're going to only have 51, right? So when we are doing these calculations, we need to specify if we're going to replace or not replace. So it's possible that maybe you're playing a game where you put the card back into the deck before you draw the second card, and in that case, it would still be out of 52 cards. But in the case where you are keeping the cards in your hand, instead, you are not going to have 52 cards left. You're only going to have 51 because you've got that ace already in your hand. So when we account for replacement, we end up with 4 out of 52 times 4 out of 51, because there are still 4 jacks left, but now there's only 51 cards in the deck. So we're going to have 16 over 2,652, and that's going to give us 0.0060. And so if we go ahead and multiply that by 100, that's going to give us 0.6%. So the rule number 5 is to account for replacement. And so that's going to give us a probability of 6%.